My name is Matthew Verick. I'm a mechanical engineer at NASA's Goddard Space Flight Center. Right now, I'm working on our generative design and evolved structures team. NASA Goddard is one of the largest centers that NASA has, and we do what's called pre-mission planning, pre-phase A, that type of stuff, into prototyping, designing, executing, launching, and then ultimately disposal of satellites and other missions. What we're trying to do is we're trying to change the scale of making parts from months and years down to days and weeks. Generative design is a method of making, for right now, structures for any one of the NASA missions. And what we do is, instead of a traditional design, what we're doing is we're actually taking the requirements of what does this thing have to do and what environment does it need to survive in, and then building the structure from there. What we've seen with generative design is it's a 6 to 10 times improvement in multiple different avenues of both mass, stiffness, and design time. So it's estimated that a launched kilogram costs about $1 million. So any amount of mass that we can save and still accomplish the mission, ultimately saves taxpayer dollars. The Power Source Global Summit was a technology summit to bring together government, private industry, and universities and things like that in order to exchange information, ideas, and best practices to move forward and work together. NASA Goddard was asked to present our vision to reality. How do we take a vision from inception into reality? And so we immediately went, well, we then clearly need to have a vision of everyone at the conference, and then we want to have something at the end of it. We thought, hey, what we're gonna do is we're gonna come up with a scenario of something. We wanted to look at lunar volatiles, so basically gases and things that are emitted from the moon's surface when sunlight hits them. And how would we capture those? The only thing that we really had kind of set in stone was we had a 250 milliliter Erlenmeyer flasks, and we said these are going to be our stand-in sample collection containers. We actually solicited input from the crowd of, hey, what are some best practices? What are things we should do? How should this sample collection container function? The awesome part about it was we didn't know what we were going to make at the end. We had reached out to Protolabs beforehand and said, hey, we're interested in having a part made. This is the timeline. Our keynote was at 10:30 on the first day of the conference. We concluded around 11:30. We took those requirements from the crowd, and then in a matter of 3 to 4 hours, came up with a generative design of an object that could hold the sample collection containers. And then about 4:30 or so, I had a completed design that would work and meet all of our requirements. We were able to send the part off to Protolabs, and they were able to make it in less than 24 hours.
I'm Greg Pers, Senior Manufacturing Engineering Manager. The opportunity came up. We weren't aware of the size of the part. We had some general guidelines about it, and then that it was going to be a one-day quick turn. The part was uploaded at 9 o'clock. It finished tool pathing shortly thereafter. At that point, it had 19 hours of milling time and then about 4 hours of manual processing time. A lot of it is completed by our automated software, but then also out on the shop floor, that is where the human element comes in as well. So we had somebody going out and checking on it, checking on progress, making sure that there were no alarms in our automated milling process that would stop it from progressing. So what makes it really unique is that the part was designed using generative design, but it was designed using all of our parameters within our manufacturing process. So it was something that could get kicked out and run through without any issues. I think 5 o'clock was our deadline, and I think the first parts made it out at like 4:31. This part went through very, very quickly, went through pretty painlessly.
The next morning at about 7:30 in the morning, parts were there in hand. We were just absolutely beyond stoked. One of the things that we did when we were demoing the part was actually held dry ice up to them, and we were able to collect some volatiles from dry ice and the atmosphere around us in those, and kind of show the crowd how we would do that. Almost everybody came by on Wednesday just to be like, that was awesome, to see that you guys came through. And we actually got a lot of questions about like, okay, how much of this did you actually plan ahead of time? How much of this was pre-coordinated? And it was like, really none of it. As an engineer, anytime that you design something and you spend time, ideating on something, and oh, this should look like this and it should work like that. Part of the reason why I'm an engineer is I love that, I designed this thing, I made this thing. We actually had the whole team kind of gathered around, and we had the parts still wrapped in the Protolabs bags, and so we opened them up, and I don't think there was a single person who didn't just like, that looks awesome. We were just very happy with how it turned out.